ಲಾವಣ್ಯ ಸ್ವಲ್ಪ ಕಳಿಸ್ತೀನಿ, ನೀವು ಕರೆಕ್ಟಾಗಿ ಬರ್ಕೊತೀವಿ ಹೆಚ್ಚು. ಓಕೆ, ಹಾಂ ಮ್ಯಾಮ್ ಬರ್ತೀನಿ. Gorable sir? Gorable sir?
Madam, is it audible?
Yes, sir.
Ah,
Sir, can I go live?
hello?
Sir, Kaveshri ma'am asking that she can go live.
Yeah, please. Yeah, immediately.
Okay, Bharat sir, ready dara? Elidara? Illa ma'am. I'll call him. ನಮ್ದು ಮ್ಯೂಟ್ ಆಗಿದೆ, ಇಬ್ಬರದೇ ಮ್ಯೂಟ್ ಆಗಿದೆ. Gorable sir? ನಾನು ಯಾವಾಗ ಮಾತಾಡೋದು? ಒಂದು ನಿಮಿಷ. Gorable sir? ಒಂದು ನಿಮಿಷ. Gorable ಇದು ಹೋಗ್ತದೆ. Hello sir? Sir, you can log in. You can log in, sir. Please settle. We are in the lab. ನಾನು ಯೂಟ್ಯೂಬ್ ಇನ್ನೊಂದ್ಸಲ ಚೆಕ್ ಮಾಡೋಣ.
Hello? Yeah.
Hello sir? Sir, can you log in? Yeah, sir.
PG sir. Hello. PG sir.
Sir? Hello, sir. Can you log in now? Yes, sir. Yes, sir. I'm admitting you. It's your turn.
Yes, you are right.
DB.
Sir, good morning, sir.
Good morning, Professor.
Sir, am I audible?
Yeah, fantastic. No problem. Just wait for 1 or 2 minutes. Participants still to join. Okay.
Sure, sir. Definitely.
Sir, good morning, sir.
Good morning, sir. Good morning. So, good morning, sir.
Good morning.
What still to join? Sure.
Kaveshri madam.
Yes,
Kaveshri
sir.
madam.
Yes, sir.
No, yeah. Kaveshri madam.
Yes, sir.
Hello.
She's outside. She's outside.
Hello. She's muted.
Yes, sir.
Madam, shall we start or we have to wait? At 9:59.
Yes, sir. You can begin the session.
Yeah.
It's 10.
Very good morning to everyone gathered in online. I welcome Principal Dr. Basavaraj L, sir, Head of the Department of Computer Science, Dr. Puttagoda, sir, various deans, the institute, and heads of the department, and faculty members, and the students, and various faculty members of the various institutes, and my dear colleagues. It's a great privilege to me to welcome and to introduce today's guest, today's resource person, Dr. Bharat Bhushan SN, for this webinar on industrial application of natural language processing, a case study of text classification as a part of decennial celebration. Let me introduce Dr. S.N. Bharat Bhushan, born in the year 1987 on February 15th at Shivamogga. He did his schooling at various schools of Shivamogga. He completed his PhD on NLP and machine learning from VTU Belagavi. He completed his master's in computer science from University of Mysuru. He did his Bachelor of Science at Shivamogga. And his skill sets are scripting, programming, core knowledge of C, data structures, Python, Anaconda, so many tools. He's having a wonderful skill set he's having, and his core competencies on machine learning algorithms, hands-on knowledge in natural language processing, and he's having good programming and algorithm development knowledge, and he's having a vast experience on various projects he's handled like SARA entity extractor, mortgage documents. At the same time, he is having experience of as a teacher. He contributed at Sahyadri College. He contributed as a data scientist at Karja Technologies, Mumbai. And he is right now working as a data scientist on NLP domain at Straviso, Pune. And at the same time, he is a wonderful articulator. He has published plenty of papers on NLP, machine learning, image processing, the journals like Elsewhere, Springer, and he has also contributed in pattern recognition letters. And also, he has worked as a reviewer of Elsewhere. With this brief introduction, is the vast contributions are there. Let me, because of the shortage of time, I would not go to in a deeper way. Uh, with this, I welcome Dr. S.N. Bharatbhushan on this webinar as a resource person. Uh, I request him to present his thoughts with respect to this natural language processing. I request Professor Bharatbhushan to present. Over to Dr. Bharatbhushan. Over to you, sir.
Thank you, sir. It's a great privilege for me to present, the industrial applications of NLP and with a case study of text classification to the ATME College, Mysuru. So actually, like first, I would like to thank Gorbal sir. Actually, he is my mentor. So he has seen me from the first day. So like as a struggling faculty, and then I like his motivational words have transformed me or molded me to some stage in my life. So thanks for all your support and mentorship, Gorbal sir.
Thank you, Bharatbhushan sir, for your words of wisdom.
So let us start our journey in the in the path of industrial applications of NLP, and by considering a case study of text classification. Okay, so the flow of presentation will be as follows. So I'll be presenting the importance, or I can say introduction to NLP, and then text mining classification. After that, I will be touching upon the applications, and I will be touching about what are the challenges what we we are going to face when we handle these applications, and then I'll consider text classification as a study. Okay, so a case study where I will be focusing on theoretical aspects as well as practical aspects. Okay, so when we observe the complete presentation as a whole, so we can see three important aspects here. So as it shown in the below thing. So first I will be presenting the introduction, next will be on the theoretical study, next will be on the practical demo. So in the practical demo, I will be considering some data set, and then I will be demonstrating through a couple of machine learning algorithms and the evaluation metrics like precision, recall, F measure, and how to if anyone follows this practical demo, so that will be their one of the project for the BTech. So this is all. This is what the whole idea, or I can say whole roadmap of this presentation. Okay. So basically, what exactly is NLP? Okay, so NLP, ML, deep learning. So these are all buzzwords, right? So buzzwords means like it will catch the importance, or I can say anyone will be one if anyone listen this word, they'll say, okay, what is this NLP and all these things. Basically, unknowingly, we are already using these domains in our daily life. Okay, basically NLP is a branch of AI and ML, so which deals with the computer linguistics. Okay. So the linguistics means how a human being can interact with the computer using natural language. So this is what we call it as a natural language processing. Okay, so this includes text data and also speech data. It means if you write something like when we consider a case study of chatbot. Okay, so the chatbot should understand the text data, and it should act according to the request from the user, right? And one more thing is the speech recognition, right? Okay, so when we consider these two things, so text and speech combinedly presents a domain called as natural language processing. One of the more complex challenge here is we need to understand the complex semantics, right? So on which context user is telling what are the domains, or I can say what are the requirements from the user. So we need to understand that these are all the challenges, right? Okay, in brief, okay, basically it is a branch of AI, okay, which deals with the interaction between the computers. It is not supposed to be computers. We can think of Alexa, right? Alexa is a computer, is a device where using that we can do, like, we can listen some songs, we can listen some news, or we can listen some whatever we want, right? So okay, Google, Siri. So as I mentioned earlier, so unknowingly we are using NLP in our life. Okay, so without these applications, so our life will be little difficult, right? Basically, when we observe, okay, so when we talk about these things, NLP, is a very big domain. So when we narrow down our observation, okay, so when we start digging NLP into deeper aspects, we can find one major thing that is called as text mining. Okay, so as I mentioned, so text mining is one of the major domain, or I can say major subset, which is present under NLP. So basically, in case of text mining, so we will understand the text data, we will do analyze, understanding, analyze the text data, and what we want to do is we want to transform the unstructured data. Basically, text is unstructured data. We need to transform the unstructured data to the structured form and extract some information out of it. Okay, for example, when we consider email spam filtering, right? So machine learning algorithms or NLP algorithms will not understand the raw text, right? So what we need to do, we need to transform the text data into numerical form so that computers or devices can understand it, right? So this is what we do in the case of text mining. Okay, so some of the industrial applications, okay, some of the industrial applications, I cannot present all the application, but here are some of the major, or I can say dominant applications, we can say. Intent classification. So intent classification is the core part in case of chatbot. Okay, so in case of, when we consider a chatbot, the data, how chatbot will be configured will be, they will be having something called as intent followed by utterances. Okay, for example, if I say hi, good morning, right? So person A may tell like good morning, or person 2 may tell hey, good morning, right? So all these called as utterances, and intent will be good morning, right? So based on the various utterances, so intent will be there. I mean, based on the intent, we are going to identify what is a user request, right? I may tell I want to listen Kishore Kumar song, right? So it is one utterance. And someone may tell like I'm interested in old Hindi songs, right? So it means what both the user are requesting, we want to listen songs, right? So this is what the important application of NLP on text domain. And the next one is spam filtering. So this is what we are already using in our Gmails, right? So when we consider Gmail, so when we get some advertisement mail, or when we get some fake offers mail and all, so we will classify it as a spam mail, right? So it will understand. So once we do for some specific mails, after some time it will learn automatically, the system will learn automatically, right? And the second one is sentiment analysis, right? So when we log into any Amazon, Flipkart or anything, so after looking at the product, immediately we'll go for the reviews, right? So based on the reviews, we will see how many are given positive, how many are given negative, right? So this will also impact in the purchase of a product, right? So this is one very, very big industrial application. And document summarization. Okay, so when we consider Donald Trump's speech, so he will give somewhere around 2 hour speech. So out of 2 hour speech, I want to take out the gist of the speech, right? We'll consider document summarization, information retrieval. For example, I want some bank transactions of 2012. Okay, so we will retrieve the document based on some category, some date, right? Document indexing. So these are all the basic, or I can say dominating applications of industry where NLP and text mining are extensively used. Okay, so this is one simple example. So here a user is requesting to book a hotel. Okay, the intent is book hotel, and let us see how the conversation goes. Okay, so user will tell, I would like to book a hotel. So the system will understand, okay, user is requesting, or I can say user is raising the request for book a hotel, right? Then the system should ask, okay, which city? Okay, he will tell New York. And when do you check in, right? So in this way the conversation goes when in case of chatbot. Okay, so this is one very good application of NLP and text mining. Okay, so one thing is the next one is sentiment analysis, right? As I mentioned, so we will look into the sentiments, what are the reviews are saying, their positive reviews, or how many positive reviews are there, how many negative reviews are there, how many neutral reviews are there, right? So we will consider that, and then we'll go for whether we should purchase that product or not, right? The next one is document summarization. Instead of considering all other things, so we'll consider only those terms which are very important, right? So we want to extract the gist of the document, right? And the next one is document indexing. So when to index as per the dates, or as per the topics, as per the authors, or as per the publication, or some any other requirement, right? So the core engine in all these applications is text classification. Okay, so when we consider these dominant applications of industry, or I can say NLP, so the core part is text classification. Hope now you will understand the importance of text classification. So text classification is one of the major aspect, or I can say major core engine, which is present in most of the application. Okay, so because of this, okay, so I'm taking you through a journey where we will be understanding the importance of classification and stages involved in classification, how a text data will be transformed into a machine understandable language, and what are the methodologies are there for the conversion. Conversion means when you consider a text data, so it has to be converted, transformed to a machine understandable format. So what are the methodologies are there, which one we should consider? So all these things, or all these, we will find answers for all these questions today. Okay. Okay, then basically what is a classification? Okay, or what is text classification? Okay, text classification is when we have given some labeled examples. Okay, so I am having somewhere around 10 documents, but I know out of 10, 3 are from politics, or 3 are from sports, and 4 is from entertainment, right? So when we consider all these documents, so if we understand these 3 documents, I mean these 3 domains of the document, if unknown documents if we give, so if we are able to classify it as a politics, or a sports, or a entertainment document, then this is the whole part of the classification. Okay, given a labeled examples, it may be labeled examples or concept. Okay, so generally we call this as a training examples. Okay, so with this, if a machine is able to say, okay, if a machine is able to classify the new document, we say it as an unknown document, or I can say unseen document, predict the class, whether it is a politics, sports, or entertainment, then it is a process of classification. Okay, in general terms. Okay, so I want to say just when we think of a simple language, okay, in a simple language, it is a database. In the database, I'm having some n number of documents. I don't know whether these documents belongs to the same class, or same domain, or same concept. Okay, so what I need to do, if I want to segregate them, so this is what is expected, right? So all the red documents should come under red class, blue document should come under blue class, right? And so forth, right? So how we can build this application? Okay, so this is what so when this is the broader aspect. So when we still narrow down our observation, how we can build, yeah, we are having 3 options to build such applications. One is rule based option, one is machine learning, and one is deep learning. Okay, so when you consider rule based aspects will be very good for some set of document, okay, or some set of use cases. Okay, so building a generalized rule, or I can say building a generalized rule-based classifier is near to not, impossible. Okay, so it is very, because we need to define rule for each document and all, which is very hectic. And the next option is machine learning. Yes, so we are going to understand the concept of classification using machine learning algorithms today. There is one more option called as deep learning. So yeah, of course, when we look at the reviews, or I can say when we look at the literature, so deep learning algorithms are giving very good results compared to machine learning. But at the same time, it is having some drawbacks also. So deep learning algorithms should require large quantity of corpus to provide high efficient data, or I can say high efficient results, right? So majority of the companies, we don't have that much of data. So we will focus, as an industry person, we will focus mainly on machine learning algorithms. Okay, this is the general architecture of classification system. So we'll be having pool of documents. So first, what we need to do, we need to pre-process it. So what do you mean by pre-processing? Pre-processing is nothing but stemming and stopward elimination. I'll go in detail with that. Then we'll represent it. So represent it in the form of n-grams, and then we'll go for classification or clustering. Okay, so clustering is unsupervised learning, so which is a part of ML. Okay, let us see what are the challenges. So basically, it is a unstructured data. So handling unstructured data is very challenging task, and the volume. So since I can say the algorithms and the data structures to handle these data remains constant, but the data is growing exponentially nowadays. Like dimensionality, when we think of representing the data in the memory, so dimensionality of the feature matrix is exceeding like anything, and the sparsity. So a small document may have very long vector representation based on the dataset availability, and the complex semantics. Understanding the complex, language is a challenge. Okay, now let us get into a case study of classification. Basically, I would love to see this case study from two aspects. Okay, so first part, I will be focusing on theoretical aspect. We will solve one text classification problem, then we will go for the practical implementation. Okay, yeah. Here in this theoretical study, I'm considering multinomial naive Bayes algorithm. Okay, so for that I'm considering the scikit-learn free machine learning library for the Python programming language. Okay, so even though there are potential algorithms are available, for example support vector machine or something else, but since we are starting from the scratch, so it would be we should go step by step. So for that I'm considering naive Bayes algorithm, and understanding the conditional probability, all these things, and term frequency matrix, all these things. Let us understand one by one. Okay, so when we consider a text document, okay, so a text document is a hierarchy, or I can say we can see a text document as a hierarchy of words. I mean, collection of words will form a sentence, collection of sentence will form a document paragraph, collection of paragraph will form a document. It means when we want to process a document, so the most important feature is word is the important feature, right? It means what? We need to work at the word level when we are building a classification system. It means what I want to tell you here is, so word is the word or term is the important feature for any NLP or text mining application. So here the random variables, in case of naive Bayes, the random variables will be word, and we will find their frequencies with respect to the document, and then we'll find we're going to build a classifier system. Okay, so we will find the word frequency with respect to our classes, and then we will find we will train the algorithm to get the result. Okay, the outcome, what will be the outcome? For example, when we finish training, we need to evaluate the algorithm. We will provide the unseen document to the system. The unseen document, if the model is able to say, okay, this belongs to any domain, say politics or entertainment or sports, with respect to our previous example, then that will be the outcome of the document. So the algorithm will give us the class name. Okay, basically this works with the background of Bayesian rule. Multinomial naive works with the with the help of Bayesian rule. So these are all this is the formula and this is the explanation for that. Okay, this is like the major goal of this is to hypothesis is given for the training, so the maximum posterior hypothesis. Okay, so when we achieve this, we will get the good performance. Yes, let us consider some examples. Okay, so here we are having 5 different documents. Okay, and sixth one is the unknown document. So we don't know about the sixth one. So let us understand one by one. So document 1 is follow-up meeting. Okay, second one is free cash, get money. Third one is money, money, money. Fourth one is dinner plans, and the fifth one is get cash now. Okay, so document 1 to 5 are the training classes, or I can say training data. Okay, so with that we have given the label as document 1 as not spam, document 2 and 3 are spam documents, and the fourth one is not spam, and again fifth one is spam. Okay, so this is the knowledge what we have got now. Okay, using this knowledge, if our learning algorithm is able to say document 6 is spam or not spam. Okay, if it is a spam mail, we'll see how it will come as spam mail. If it is not spam mail, so we'll see how it will come as non-spam mail. Okay, so basically the algorithm will calculate the probability based on the previous results, right? So what are the previous results here? Previous results is nothing but the domain name or class name of document 1 to 5. Okay, so with this, let us continue our discussion and understand whether document 6 is a spam mail or a non-spam mail. Okay, so as I told, any learning algorithms cannot understand the text data as it is, right? So what we need to do, we need to transform it. So how we need to transform, or what is the important feature of that, right? The important feature is the term, right, or word, right? So when we consider the word, so we will construct the term frequency matrix for it. Okay, when we consider each term present in document 1 to 5, the term frequency matrix will look like this. Okay, so for example, follow-up. When we consider the first word follow-up, the follow-up is present 1 time in non-spam, and it appears 0 times in the spam. Let us confirm it once again. Yes, follow-up is present in document 1, which is present in the non-spam mail domain, and it is not there in the spam mail domain. Okay, so similarly, the same sort of calculation will be done for all the terms which are present in document 1 to 5. Okay, so when we consider, or when we look at this matrix is called as term frequency matrix. Okay, so we will capture how many number of times the term is present with respect to the domain. Okay, now let us consider the term money. Okay, so when we consider the term money, money appears 0 number of times in non-spam. It will appear 4 times in the spam domain. Okay, it means the weightage of money is more in case of spam. Okay, so when we sum up all these term frequencies of non-spam and spam, it turns out to be the total population. We call this as a population. Okay, so non-spam is having the population of 4 and the spam is having the population of 10. Okay, next our next step is to find the conditional probability. So how we will find the conditional probability? So conditional probability can be calculated as the frequency of the term divided by the total population of the domain. Okay, now let us consider the follow-up. Okay, follow-up is the term, okay, which is appearing 1 time in the domain called as non-spam, and the non-spam is having the population as 4. Okay, the conditional probability of the follow-up will be 1 divided by 4. It will be 0.25. Okay, so and when we consider the one more example, money. Okay, money is appearing 0 times in non-spam, so the conditional probability will be 0 divided by 4, which is 0, and the 4 divided by 10, which is 0.4. Okay, so this is the conditional probability with respect to class. We will see how I mean, what is the relationship between the term with respect to the class? Here, non-spam is a class 1 and spam is a class 2. Or I can say in other words, like what is the weightage of term with respect to the class? Okay, we'll see that. This is what we call it as conditional probability. Okay, and we need to find the class probability. Okay, so class probability, how we will calculate is probability of non-spam is equal to uh, class population divided by total population. Okay, so we can see here class population is 4 for non-spam and the total population will be 14, right? 10 plus 4, right? So the class probability will be 4 divided by 14, which is equal to 0.2857. Okay, now with respect to spam, the class population for spam was 10, right? So 10 divided by 14 will be 0.7142. Okay, this is one example, non-spam class 1 population divided by total population. Now we have probability of each class and the conditional probability and the posterior and now we need to calculate prior probability for document 6. That's what we are doing, right? So we need to provide the class name for the document 6. We don't know whether it is from spam mail or non-spam mail, right, or non-spam domain. So we need to find that, right? So to find that, we need to calculate the prior probability. Now see, now let us continue our understanding. So how we will calculate that? Okay, so that will be probability of the given document, get money now as a non-spam will be calculated with this formula. So which is presented here, probability of get multiplied by money multiplied by now multiplied by class probability. Okay, that is 0.2857. Okay, with respect to the spam, the same thing followed by 0.7142. Okay, but we need normalization. We need to do normalization for that. So for performing normalization, we need evidence. Okay, so evidence is calculated as probability of get, okay, with respect to omega 1 or say class 1 multiplied by class probability and probability of the same word, that is get, with respect to omega 2, that is class 2 multiplied by class probability. This will be the prior information with evidence. Okay, now when we consider the term probability of get for a non-spam, that will be 0 multiplied by 2857, which is the class probability of non-spam, divided by 0.1428. Okay, so which is 0. Okay, and for spam it is coming 1. Okay, so this is probability of what will be the probability of get for the given domain non-spam. Okay, so for non-spam we got 0 and for spam domain we got it as 1. Okay, now we are having still 2 more words. Let us see how it will goes. Okay, now we are doing the same calculation for money. Okay, so what was the document 6? So document 6 was get money now. Okay, so we got the P of get, right, probability of get value. So we need to do it for probability of money and now for non-spam and for spam. Okay, yeah, this is get, and now we are doing it for money. Okay, so when for money the value for, the prior value for non-spam will be 0 and the spam is equal to 1 based on the evidence calculation values. Okay, and also for now. Okay, and also for now it is also 0 for non-spam and for spam it is coming 1. Now what we need to do, we need to calculate the values. Okay, now the calculation is as follows now. So probability of get with respect to non-spam is 0, money is 0, now is 0, and class probability will be 0.2857. So anything multiplied by 0 is 0. It means it is we are sure now the probability of get money now is not related to not spam domain. Okay, the next one, let us think of the one more remaining domain, that is spam. Okay, so here we are performing probability of get. So probability of get got 1 and money also got 1 and now is also 1. Okay, multiplied by class probability, that is 0.7142. So 1 multiplied by 0.7142 is equal to 7142. Yes, the higher value indicates the higher probability. It means the document 6 which is get money now, is directly related to the spam domain, okay, based on the probability score what we are seeing now. Okay, now the classifier will give us the result stating that document 6 is a spam domain, or I can say spam mail. Okay, now let us get into an understanding of, like, this is till now what we have understood is the theoretical aspects. So how we are going to solve a problem when we consider the learning algorithm as multinomial Naive Bayes algorithm with a simple example. Okay, so when we want to develop this, okay, so when we want to develop this, so we need some libraries and some data sets and all. So let us understand a demo, okay, a practical demo. We'll see practically how we are going to build a classification algorithm now. Okay, I will be moving to Jupyter Notebook. Okay, so this is one IDE, or I can say Jupyter Notebook is an development environment for Python. So this is one popular one. The next one is Spider, and the next one is PyCharm. Okay, so it is up to the user, so where he's feel comfortable, so he can go into it. So all these three IDEs are same, like is extensively used for you know development. But PyCharm is having one advantage. So if you want to deploy code in the server, you can directly deploy code from the PyCharm. So here we cannot deploy that. So we need additional softwares like Qt or FileZilla or these things. Okay. So these are all the libraries which require for us now to understand the practical demo. Okay. So import RE, so the regular expression we need to see, right? So now how some of the data need to be removed from the some stop words, or I can say some symbols need to be removed from these things. So maybe BTech students will be aware of these things, since these things are there in the Python module, regular expression, right? So operating system, pandas, numpy, all these things. Okay, so these are all the libraries. So I will run this. So you can observe if the cell, these things are called as cells. Okay, so this entire block is called as a single cell. Okay, if the number is appearing it, so it is run already. Okay, if the number is not appearing, so it is not run. Okay, yet to be run. Okay, so the first cell is run, it means we have successfully imported all the libraries to the system, or I can say this program. Okay, so we need to understand that. So here I'm using one data set. Okay, so this data set is a very known data set that is called as 20 news group data set. Okay, so like I'm considering the one of the popular data set for the classification, 20 news group data set. Okay, yeah, now when we observe this, yeah, I'll continue this. Okay, we'll go one by one. Okay, so this cell is also run now. So we have read that data set now. So I'm reading from the XLS, I'm reading it as Python sorry, pandas data frame. Okay, so data is read now. So we are having two columns, one is data column and one is label column. So this is what we consider it as trained data. Okay, sorry, this is the exact data. Now I'll tell you so how we'll split it, and then how we'll go for train and test split. So this is what the data is now. Okay, so this is a number of samples here, somewhere around we are having 2000 samples, and labels and all there. Okay, so this is one functionality of that. So what is the data set size? So data set size is 1994. Okay, yes. Now I need to define some of the regular expressions to perform some sort of pre-processing. Okay, so some sort of pre-processing. So why do we require that? Okay, so the first question is, why do we require these pre-processing techniques? Okay, now when we observe the data, we are having some numbers in between. Okay, some digits. Okay, and some symbols here. Okay, and there is one more symbol. Yeah, some of the symbol. Actually, when we are building a classifier, these digits or symbols can be treated as noise. Okay, so this will not this will not enhance the performance of the classifier, or this will not considered as a feature itself. So we need not to have these things in the data set. So what we need to do, we need to remove them. So how we can remove them? So what I'm doing it here is I'm calling a loop. I iterate through the loops, and if I find a digit, so this is the regular expression for the digit, so I will replace it with the null. If I see anything with a special symbol like greater than, I'll replace with some empty string. Okay, the same thing I'm doing. And news group is the common term which is appearing across the classes, right? So we can see here news group, news group, news groups. So we don't want that. Okay, so I'm also I'm replacing that word also. Okay, now, and at the end I'm storing it in the new column called as data1, right? So we are having, as of now, we are having data column and the label column. So what I'm going to do, I will take this data, I will iterate through the loops. Okay, I'll take one by one, I will perform it and create a new column here called as data1, and I start loading it, because we can visualize what are the changes, right? So let us run this cell. Now we can see this, right? So this number is missing here, right? And this special symbol is missing here, and the news group is missing here, right? So this is a sort of pre-processing. So a simple sort of pre-processing where we will try to remove the data, or I can say noise, which is not required for our application. Okay, application, or we can say use case. Okay, so this differs from use case to use case. Okay, so when you are building a sentiment analyzer, or I can say sentiment analysis application, the noises will be different, or when you're building chatbot, noises will be different. Okay, so as I mentioned, it depends on the use case to use case. Now we cannot directly load this data to the classifier. So what we need to do, we need to perform some more pre-processing techniques. So what are those pre-processing techniques is, we want to remove stop words from the data. Okay, basically what is stop word is, when we consider a sentence, we will have some words like is, as, where, when, all these things, right? So this will not this will not preserve any domain information. So what we'll do, we will remove those data those terms from the data set. So for that I am using NLTK corpus. Okay, from the NLTK corpus I'm downloading the data set. This is one of the widely accepted corpus for natural language applications. The language, the library name itself is like the natural language toolkit. Okay, NLTK means natural language toolkit. So from that I'm downloading the stop words. Okay, and I'm performing stop word elimination with the lemmatization also. Okay, so basically I am removing the stop words, that is, where, when, and all, and lemmatizing it. Lemmatizing it means I am bringing the word to the root form. Okay, so here the word will be transformed into the root form. So this will help us to maintain the data in the normalized way. Okay, so basically what I'm doing here, see here, first I'm dropping the NaN columns. If any NaN columns are there, that is not a number column, it means some garbage data is there, that will be removed. Then I'm converting it to the lower case for the all the data. See, I'm considering the data column as data column is data1. Okay, so as I mentioned, so this is our original data, this is the transformed data, then now it is in the data1. So I'm considering the same column here, and I'm converting it to a lower case. Okay, then I'm tokenizing it. Okay, so as I mentioned, we need to concentrate on the word level, right? So what we need to do, we need to tokenize it, and then we need to perform the operation, and finally I am creating this in the new column called as data final. Okay, let us run this cell. We can see the output. Basically it will take some time, because here couple of operations are merged here. So one is converting it into lower case and tokenizing it, and stop word removal and lemmatization. 4 operations are merged in the same cell, so it will take little time. So no problem, we will see how data got transformed stage by stage. So how it will be transformed to stage 1, and the next is stage 2, and all. Okay, and the data set is also a little high. Yeah, now we can see here. This was our first data column was the first the raw text which we have considered initially. We have transformed it into a different thing, like with the stopward elimination, like all these things. You can see the digits and all removed here. Okay, so after that we have converted into a token, right? So token, we can see here, this is one token. Okay, this is one more token, this is one more token, like that, and we have converted into a lowercase. By default in this data set we are having lowercase, no issues with that. And then we have performed stopward elimination and these things also, what lemmatization also. Okay, now we can see here, what do you mean by stopward elimination? See here, for example, we are having the term the here, right? So the term is missing here. It means what? The term is removed because the is will not preserve any domain information. Okay, so we have removed that. So what we need to do now, we need to consider label column as well as data final column for our building the building the application. Right now, this is a simple step for EDA. So in any industry, when we get the new data set, we will try to perform the EDA. EDA is exploratory data analysis. Okay, so we will see how many classes are there and what is that class this will give us an idea if any class is having very less number of samples. We need to build the algorithm in a different way, because the data set, we call such data sets as are skewed data sets. Okay, so we need to perform differently. So for that we will perform the EDA. So EDA, as I told, it is exploratory data analysis. Okay, with now the data set what we have considered is having no problem, no issues, because all the classes are having same number of samples. But somewhere here class 3 is having less number of sample, it is fine. So it will not create any problem as such. Okay, now we can move further. Now we have reached the stage where we need to divide the data set into 4 different parts. One is train X, that is train X is our data, and train Y is our label. Okay, so label means the class, the data set label column, as I told. So this is the label. Okay, this is the data. Okay, so what we'll do, we will import model.selection train text split. Okay, this is there in the scikit-learn. Okay, and then we'll pass the parameters as data set final and the label. Okay, this is the actual content and this is the label for it. Okay, so in case of our theoretical example, document 1 to 5 were there, and labels are spam mail and non-spam mail were there. No, so it is similar to that. Okay, so with that, what we'll do, we'll split it into train X, test X, train Y and test Y, and we will define what should be the test size. Okay, we can go for the train size also. Here I am defining test size as 0.3, which means if you have 100 samples in the data set, so 70% will be go for the training and the 30% will go for the testing. Okay, and we are having random state is equal to 20. So approximately, I mean that when we run this trial again and again, the samples between the train and test will be shuffled. Okay, this will help us to evaluate any learning algorithm. Okay, now this is one of the most important aspect of application. So what we need to do now, we need to convert the text data into vector form, right? Or I can say numerical form. Okay, so the widely accepted methods are count vectorizer and the TF-IDF vectorizer. Okay, so I will insist to go with the TF-IDF vectorizer. I will show you why it is important. Okay, so let me run this code. See, the given data, for example, this is the corpus. Okay, so this is the corpus. So from the corpus, I have performed the stopward elimination. See here, stopward is equal to English. Okay, see, I'll explain this one first. So what I have done here is I have created the count vectorizer instance, and with the count vectorizer instance, I have passed a parameter that is stopward as English. So I'm performing stopward elimination here, and then I'm going for creation of a matrix. Okay, this is the DTM matrix. Okay, document term matrix. Okay, This is the matrix. Okay, I have considered a different example. I will show it in the Excel, so that will be more clear for the understanding. Okay, this is one way of representing the text document in the form of a vector, or I can say number, and this is one more form, that is TF-IDF vectorizer. Okay, the same examples I have considered here, so this will give us the more clarity than this. So we can see, so the house had a tiny little mouse, the cat saw the mouse. So the same examples, and these are all the same matrix which I have generated just now. Okay, now when we consider this, okay, so how count vectorizer will work? Okay, how count vectorizer works is, consider this is the document 1. Now this row represents document 1. Okay, so this row what I have highlighted now represents document 1. In the document 1 there are some entries with zeros, as well as there are some entries with 1. Okay, so what represents, like, if the entry is equal to 0 means the term 8 is not present in the document. Okay, so in the first document we don't have the term 8. Okay, we have the term house in the first document. Okay, so this is what the count vectorizer, it will try to see if the term is present in the D1, that is document 1, it will make the entry as 1. If the term is appearing 2-3 times, it will make it as 2-3. Okay, now see here, this is what the count vectorizer is. Okay, now this is what the TF-IDF. Okay, TF-IDF is term frequency and inverse document frequency. Okay, now let us consider what is the difference between these two representation techniques. Okay, now see, we are having house here, little here, and mouse here. Okay, the weightage for these three terms are same. The weightage for these three terms are same. Okay, with respect to document 1. Okay, but the weightage for these three terms are different with respect to TF-IDF representation. Okay, let us understand in detail. Now when we consider the term mouse, okay, when we consider the term mouse is present is in all the document. Okay, mouse is present in all the document. It means we can treat this as a kind of stop word, because using mouse we cannot take any decisions. Okay, since it is present in all that document. Okay, but the count vectorizer will fail to preserve that imbalanced data, or I can say will fail to preserve this nature. It will provide the high entry to all the documents with respect to the term mouse. But when we consider TF-IDF, see here, even though little is also appearing only one time and the mouse is also appearing one time, the weightage for little is different than the mouse. Okay, means the mouse, since the term mouse, since it is appearing in all the documents, is having less weightage in all the documents. It means the term mouse with respect to TF-IDF is not an important term. Okay, as per the TF-IDF, the term little is important. Okay, house and little are important, and here also tiny. These three terms are important for document 1 in case of TF-IDF. If the term is present in all the documents, such terms will not preserve any domain information. So what we need to do, we need to provide less weightage for such terms, and we need to consider those terms whose weightage are more. Okay, the same thing is there here. Okay, the same thing, to make more, to provide you the more clarity, I consider the same examples in the example in an Excel. Yes, let us consider, let us continue our discussion. Okay, so with that I am going further now with the data set which we have considered. Okay, so here we can see I am creating the instance of the TF-IDF. So from where this has come, I have imported this. Okay, TF-IDF. So I'll show you once. Okay, here it is there. See here it is there, from sklearn feature extraction.txt. I'm importing TF-IDF vectorizer. Okay, the same instance I'm using it here, and I'm mentioning stop words as English. If we don't fix this parameter, it will not perform stop word elimination. I'll show that here. Okay, so I'm deleting this. Okay, now it will not perform the stop word elimination. You can see now from is there, off is there, the is there. Okay, but if we perform the stop word elimination, okay, so those terms will not come. Okay, yes, now let us go and create a TF-IDF instance for the data what we have considered. We have considered a stop word and the data set. Okay, so TF-IDF vect. Okay, and we are creating this is the complete data set I'm taking, and then I'm transforming the train X as the train X TF-IDF and test X as the test X TF-IDF. Train Y and test Y are the labels. Okay, so this will create okay, train X is not defined. Sorry, I have not run this cell, so it is coming not defined. So I will run this cell, so it is run now. Now I'll create the vectorizer. Yes, it got created. Okay, now I need to perform the label encoder. Label encoder means we can see here when we see here, see there are like class 1, class 10 names. So instead of calling it as class 1, so each class will be assigned with a numerical value. Okay, so this operation we will perform it with the help of a label encoder. Okay, all the labels of train Y will be encoded to some number. We'll see how it looks like. Okay, so I have given, see here, so all class 13 are with the number 4 and 17 are with the 8, 19 are with the 10. This is for our understanding, that's it, because in some cases if the class labels are not proper, we can go with the assigning with the we can assign some numerical value for it. Okay, now I am creating a TF-IDF instance, and then I am performing a label operation. Okay, with the multinomial Navy Bears classifier. Okay, so I'm creating the instance of multinomial Navy Bears classifier as a CLF. Okay, I'm performing fit operation with the train X TF-IDF. This is the vector for the train samples and the label which are encoded now. Okay, so let us see how it will work. Yeah. So when we perform the operation, so we will get the confusion matrix. This is what the confusion matrix is. So for each class we will get the samples. Okay, so this is the precision, this is the recall, and this is the F measure for the performance. So we need to perform the evaluation of the algorithm. So how our algorithm is performing. So we have got somewhere around 0.79 F score for the the data set what we have considered for the algorithm, that is multinomial Navy Bears. This is one method of calling the classifier algorithm. There is one more method with the help of pipeline. Okay, so here what we'll do is we will create a pipeline. In the pipeline, first we will call TF-IDF vectorizer, and then again we will call the classifier instance. Okay, so it's very simple. Code is very simple. So this is the pipeline. So from where this pipeline has come? So from the sklearn. So sklearn import pipeline library function is there. Import operation is there. So with that we will import pipeline, and then we'll create a pipeline. We'll perform the same operation and we will print the confusion matrix. Okay, now it is star. Star means the cell is running. Yes, we have got the confusion matrix for all the 20 classes. It is from 0 to 19. Here it is from 0 to 19. Yes, it is working fine. Okay, and then let us consider some more classifiers. Okay, so let us consider some more classifiers. So here I'm considering SGD classifier, stochastic gradient descent classifier. So let us understand how it works. Yeah, this is the classifier, this thing. Now we can see the F score value is above 0.92. Let me explain one thing here. So we are having 20 classes in the data set. Okay, so this is the precision, this is the recall, and the F score column. Okay, so precision is 1 and recall is 0.83 and F score is 0.91 for class 1. Okay, so this is what now let us go for the nearest neighbor classifier. Okay, so this is the nearest neighbor classifier has given the result. We have got the confusion matrix, and this is the precision for class 1. The overall precision and accuracy will be here. This is the F score is 0.63, and next I'm going for the centroid classifier. Same code. So I'm creating the pipeline, creating the vectorizer instance, calling the nearest. This is the centroid one. Same code, just change the classifier instance. That's it. Okay, so here it is given 0.88. Okay, next one is decision tree. So this is the decision tree classifier. Decision tree has given very good accuracy, that is 0.94. And next we are having linear SVC, that is support vector machine with the linear kernel. So this is also given very good, that is 0.91. So till now we have considered multinomial naive Bayes and stochastic gradient, nearest neighbor, centroid, decision tree, and linear SVC. Okay, so results what we have got is this. So let us plot this. Okay, so what I did is I have sorted the methods with the algorithm names. So I have sorted. So it is clear from the graph. So the decision tree have given very good score of 0.94. Stochastic gradient descent have given 0.92, and linear SVC have given 0.91. The least one is 0.63 with the nearest neighbor classifier. It is not that now nearest neighbor classifier is not performing well, but for this example or this use case, maybe nearest neighbor classifier have given very less score. So this is what's about the practical implementation of a classification algorithm. So we have considered 6 different algorithms, and we have analyzed the algorithm in terms of result. Okay, so this if we change any data set and all, so the algorithm accuracy may differ. So this is what the practical implementation, or I can say practical demo. Okay, so let us go back to our PPT. So we started from the understanding of importance of NLP, and then we touched about text mining, and we have seen the applications of text mining, and we have seen the challenges, and then we understood the theoretical aspects of text classification. So how given a set of document, how it will be treated, how it will be class name will be provided for the unseen document. Now we have completed our demo with respect to the text classification. So this is what our journey was. We started with the intention to understand all these things. We have completed all these things. So thank you. These are all my coordinates. Okay, so my WhatsApp number and my email address. So if anyone wish to contact, you can contact at any time. Thank you.
Hello,
Hello. Sir.
Madam, Commissioner Madam.
Sir, for sharing
Hello,
Hello.
information. As we don't have any
hello.
queries on YouTube, I will
I request
request every participant
Madam
to
to
come and
present vote of
give
thanks.
a session.
Lavanya Madam.
In
Any questions are there?
Yes, I'm sorry. I forgot to mention. Any questions?
Kavishri Madam.
Yes, sir.
Hello. Any questions?
No
Any
question, sir. No question from YouTube. So we can.
can terminate the session?
Yes, sir. We can.
Yeah. Uh, this one. Somebody? Lavanya, no? Lavanya Madam.
We come to the end of the webinar session on industrial application of NLP. I, Lavanya N, on behalf of the ATME College of Engineering, thanks to the resource person, Dr. Bharat Bhushan, and data scientist from Pune for sharing the valuable information on NLP. I extend my grateful thanks to the principal, Dr. Basavaraju L, for supporting and motivating us to conduct this webinar as a part of the senior celebration. I thank to the HOD of the CS department, Dr. Puttegowda D, And thank to the convener, Dr. J.V. Gorabil sir, and I thank to all the faculty students for participating in this event. And I hope the same response from your side for the future webinar. Have a great weekend.
Okay, thank you, madam. Thank you very much.
Thank you,
Thank you,
sir.
Professor Bharat
Thank you.
Bhushan. Thank you very
Thank you.
much.
Thank you, sir.
In future, we'll communicate with you. Thank you, one and all.
Thank you, sir. Thanks a lot.
Thank you. Thank you.
So, no question from YouTube.